and Geosciences 2021. Today's plenary session would remark end of our ICGoeS seminar series, and the topic of our plenary session today is about academic collaboration for sustainable development georesources, which shall be delivered by two keynote speakers. One of them is Professor Koichiro Watanabe and also Professor Rude, and also three panelists. Allow me again to extend our appreciation to our sponsors, PT Georesources, Pertamina Geothermal Energy, PT Agincourt Resources, PT Bukit Asam, BP Brau Limited, PT Geopatra Solusindo Energi Pratama, Exxon Mobil Cepu Limited, Kementerian Pariwisata dan Ekonomi Kreatif Republik Indonesia, PT Medco EP Indonesia, Premier Oil Natuna CBV, and to our generous supporters, ICGoeS, IAGI, MGEI, LIPI, S3 Indonesia, Dinas Pariwisata Provinsi DIY, Kagama dan Kageogama. Last but not least, to our media partners, Trans7, Suaragama, SKM Bulak Sumur, Kleperon, dan Petroleum ID. Thank you all for your support. And now for the surprise, allow me to introduce our moderator for this afternoon plenary session. Dr. Doni Prakasa took his doctoral degree in geological engineering RWTH Aachen, Germany in 2007. He is also a project coordinator for Get in Cicero, German-Indonesian Geocampus in Indonesia for competence in education and research for organizations, UGM RWTH Aachen University. Dr. Doni also responsible as a project coordinator for CUBE ASEAN, who is recently appointed Collaborative Education Program of Urban Geology in ASEAN region. CUBE is an education collaboration involving UGM, Kyoto University, Chulalongkorn University, Hanoi University of Mining and Geology, and BMKG. Dr. Doni has done extensive research in hydrogeology and environmental geology across Indonesia. Dr. Doni, the floor is yours.
Okay, thank you very much, Ms. Icha, for the introduction. So I'm very honored today that become the moderator for two important persons, for me, myself, and for the department. A long friend of departments of geological engineering, Professor Koichiro Watanabe, and also Professor Dr. Thomas Rude, which is also my co-supervisor. So, ladies and gentlemen, and good afternoon today in the Indonesian time and Japanese time, yeah. But good morning for you, which is heard or seeing this plenary session, the second plenary session of ICGoeS from the Europe. Yeah, I know that some of you will be join this also from Europe. So as the moderator, I will moderate this plenary session and also the panelist session for today, and then we can discuss each other, yeah, for about 2 hours. For the first, I will introduce Professor Koichiro Watanabe. He is the Professor of Economic Geology at Kyushu University, Japan, and he's a leader in Applied Resources Geology Research of Japan, and got his Doctors of Science from Kyushu University, but without any years. Maybe Professor Watanabe will explain what years that he got his Doctor of Science. Yeah. And then he was the Vice President for International Affairs and the Director of the International Student Center of Kyushu University. And his field of specialization is Earth Resources Science, Hazard Geology, Volcanic Geology, Geothermal Geology, and Economic Geology. For today plenary session, Professor Koichiro Watanabe will have a presentation about 20 years research collaboration on georesources and spatial between UGM and Kyushu University with expansion to Asia-Africa Georesources Research Networks. I think The time is yours, Professor Watanabe. And according to the rule, we have about 20 minutes of presentation, and then we will continue with other Professor Tomasudo for his speaks. Please, the floor is yours, Professor Koichiro Watanabe.
Okay. Can you see my slide?
Yes, Sensei.
Yes.
Okay.
Yes, we can.
Okay. Thank you for my introduction, Donnie. I'm Koichiro Watanabe. I'm very happy to connect with all of you, especially the Georgia people. I visited Georgia and the UGM nearly 30 times for this 20 years. So this is very long history. Then this time I'd like to introduce some of our collaboration and partnership between the UGM and the Kyushu University for 20 years. I believe this international collaboration is one of the successful cases to create a large outcome of international activity each other and proceed internationalization of each university. So, although some of UGM staff and maybe young students never been to Kyushu University. Actually, most UGM staff visited us already. So at the beginning of my talk, please allow me to introduce Kyushu University very, very briefly. Actually, Kyushu University was founded in 1911 as fourth imperial university. And we have 4 campuses like this. Actually, this large one, just a minute, cursor. This large photo is showing the Ito campus, new campus, and actually campus relocation to this campus was completed 3 years ago. Now this new Ito campus became the largest campus in Japan, actually, as a single campus. Actually, the number of students are rather small as compared to UGM, around 19,000, including 7,000 graduate students. Number of international students is about 2,300. And here, more than half is from China and the next is Korea, but the Indonesian student is more than 110, like this. It's increasing, so we are very happy to accept more Indonesian students. We are belong to the Faculty of Engineering, and we have 12 departments in this engineering faculty. Our department is the third one, Earth Resources Engineering. And our departments are rather small as compared to the other departments in the Faculty of Engineering, but we have 8 professors and 7 research groups, including resource geology, my place, and geophysical exploration or geothermics or mineral processing like this. We are focusing the renewable energy research, especially the green technology such as our university, Kyushu University type wind turbine system or geothermal or organic solar cell technology or hydrogen. Maybe hydrogen research center is maybe the largest in the world. So a little bit I'd like to talk about the AUN CNET project. This project was started 2001 actually. Then pointer doesn't move. Actually, from ASEAN side, actually the AUNCnet covered 10 engineering field, and 26 ASEAN top university related to engineering are selected. And one of 10 engineering field, that is geological engineering and georesources engineering, was hosted by Gajah Mada University. And from Japanese side, it's Kyushu University was the main supporting university. Then I was involved in project from Japanese side. Actually, in Gajah Mada University, Professor Duiko Rita was the first contributor to initiate this project almost 20 years ago. So we have a very, very long history for this. Today's talk is actually originated from this AUNCnet group. As I mentioned, 2001 it started. Then the phase one started in 2003, and HI is the host institution, and the UGM was the host institution. Actually, core of this project was UGM and also from Japanese side, Kyushu University, as well as Hokkaido or other Kyoto University. So related to this starting of this AUNCnet, we have a very close and very active research collaboration and education collaboration. That was very important to start the other activity. So 2007, our group extended to promote international conference on Earth resources technology, and we had a meeting in ASEAN countries and sometimes in Japan. 2011, we have started Asia-Africa Mineral Resources Conference. That was organized by me and Dr. Yonezu and CNET member, including UGM geology members. Then 2012, this red one, AJ-BCEP, School on the Move. Actually, from ASEAN side, UGM was very important collaborator to promote this program. Then 2015, Gajah Mada University and Kyushu University started a double degree program in master course. Then, you know, the start was very small. Then we started the collaboration and the partnership, but it's enlarged now in not only ASEAN and Japan, but also including Africa. We have the large, actually large family or large research partnership covered ASEAN and sometimes ASEAN, Japan, Africa, and some other countries. So that's why this is one of the very good example of collaboration to promote the very large community for research. This is the one photo, the most beginning photo of AUNCnet project. In the center, Professor Duiko Rita Karnauti. The left is Professor Uchino, and left is me. And the beginning, those members are really important member to create our partnership in ASEAN and in Japan. Following this AUNCnet, we started Asia-Africa Mineral Resources Conference. It still continues, so already more than 10 years, I guess. Actually, instead of me, now Dr. Yonezu is promoting this program. 2011, the first meeting was in Fukuoka, Japan, and moved to Bandung, Ulaanbaatar, Mongolia, Algeria, Philippines, Japan, Akita, then Myanmar, Botswana, Japan again like that. But last year, last fiscal year, this was canceled, but still this program is continuing. From 2012, I started this AJBCEP. Actually, ASEAN Japan Build Up Cooperative Education Program for Global Human Resources Development in Earth Resources Engineering. Quite long, so we call AJBCEP. Gajah-Mada University and Kyushu University are major university to promote this program. This is one example, actually, from ASEAN country and from Japan. In Japan, actually, including Kyushu, Waseda, and Hokkaido University, students joined this program. In total, about 30 or 40 students from each country. Then they share the time together for 1 or 2 months. The different country, different place. Actually, this one is 2014 summer school organized by Gajah-Mada University Geology Group. So actually, students could visit some important place near Jogja and Solo. It's very, very important and very nice time for students. 2006, as you know, there was the Jogja earthquake. So we had the research collaboration of this Jogja earthquake disaster survey by UGM geology member and Kyushu member and some other members. Then this book was published by mainly by Professor Doikorita Karunati, and this book was donated to the how to say, Jogja, I forgot, governor. 2005, we had the JICA hiring project. Of course, not only geology, but all engineering field in UGM are involved in this program. Actually, UGM Geological Engineering Department offered one room for Kyushu University. So we are very happy for this contribution from your department to our department in Kyushu. Okay, so a little bit I'd like to introduce about the output of the research collaboration between UGM and Kyushu. The first one is by Agun Harijoko. Dr. Agun Harijoko was my first PhD student actually. So we are very close. Then he published many things, but this one is actually the gold-bearing quartz veins and hydrothermal alteration in the North Queensland in Australia. This is the result of his master thesis. So we, because of this collaboration, we did the research in Australia, but it's Agun Harijoko's main work for master thesis. Then Dr. Agun Harijoko's doctor thesis was focused to Chibarion gold deposit in Western Java. So we visited this Chibarion gold deposit. At that time, the mining was not started yet. Now it's already mining, but at the beginning, he did lots of work. This is one publication, and this is very important because he did the argon data in the United States, Oregon State University, and he got the very precise argon age data for the mineralization on Ajuraria. I guess this is maybe the first argon date for mineralization in Indonesia. So that's why this is very important and the data is very nice. This one, Dr. Lucas Donizetti Jaji, he was my third PhD student and he was the first AUN CNET PhD student in Japan, I think. And also he got the PhD in 2 years because he published many things within a short time. Then that's why for all Japan, he became the first PhD holder supported by AUN CNET. This is one of the results mentioned progress design of integrated geological analysis system. He did lots of work with us. Dr. Akmaluddin focused and also Varutono Raharjo, who is my friend, published about the Miocene warm tropical climate. This is a very important result, I think. And they found the evidence based on the oxygen isotope in Central Java. Then another collaboration is by Subagio Pramijoyo, Arifin Idrus, Lucas. And this is about the skarn in actually Batuhija porphyry deposit. Another collaboration is about the epithermal gold mineralization in Trenggalek. This is also a very important and very interesting result by Agan Harijoko, Vayan Varmada, and Idrus. Another is about the DN volcanic compression geothermal field in Central Java. This is also the main research product by Agan Harijoko and also Lucas together with us. Dr. Wafiu Wiropo did work with the very famous lady professor Keiko Sasaki, very severe person. I remember Dr. Wafiu was crying with very severe supervision by Keiko Sasaki. But anyway, this is one of the publications. They published many things, but this one is identification of sulfate and arsenate reducing bacteria in sheep manure as permeable reactive barrier. It's very important for the arsenic immobilization in groundwater. So I think I hope such kind of research will continue. Another is Dr. Ferian Angara, together with Professor Kuro Sasaki. They are really focusing the CCS research. Another is by Dr. Agun Setianto, together with Professor Mitani and Professor Esaki, focusing surface subsidence in block caving mining using GIS. Maybe there are many actually publications, but because of the limiting of time, the last introduction is about the metamorphic evolution in Indonesia by Dr. Nugroho. Maybe you know Dr. Nugroho Setiawan visited Antarctic. That is under the research collaboration with his supervisor, Professor Osanai in Kyushu University. Then Nugroho became the first Indonesian to have the geological expedition in Antarctic. So that's why he already 4 years ago, but he became a hero at the time. Anyway, this is again the same slide which I have shown. 20 years ago, our research collaboration was not so big, but gradually we started, and your UGM geology staff visited Japan and Kyushu, and we visited Jogja and Indonesia, and also Jogja staff and the Kyushu staff visited other country to do research like Australia or some other country. Then our collaboration became really big. And now I think this family is very significant and very important. So, you know, and also sometimes we can get some kind of good, big research budget from our government and also from Indonesian government or some other government. That's why this kind of collaboration is really important, I think. So lastly, this is the last slide. I'd like to express my appreciation to Doni and also my closest Indonesian friend and best project partner, Professor Dwi Korita Karnawati. This is her house, I think. And also Kyushu University alumni such as Dr. Agung Harijoko, Dr. Lucas Doni, Dr. Didit Varianto, Dr. Akmardin, Wiropo, Setianto, Nugroho, many, actually, many other UGM staff as well as Dr. Hendi Setiawan and other UGM staffs for preparing this excellent conference. I'm retiring Kyushu University this month, actually, and next month I move to Tokyo to work in JICA. So I think I have a chance to contact you again. Okay, thank you. That's all.
Thank you very much, Professor Koichiro Watanabe. What you have already given in this presentation is 20 years. It's like opening a lot on the photo, a lot of the memories, yeah, of starting in 2001. Yes, I still remember that the first activity of the JICA on SITNET on that time is opening with the research program in 2001, and then it started with 2003 started with the education program also. So I'm very happy that, and we are all very happy that you can share what's the slide that you have already presented to us to make it remember again. That is we have a long history, yeah, between Kyushu and UGM, and more than 20 years, and as a lot of things already happened, and I think the result is very good, yeah, for both of the university and also the effect also to the other ASEAN university also. Thank you very much for your presentation, but please do not leave this meeting because we will open the discussion after the end of this keynote speaker and panelist session. So, ladies and gentlemen, I'm inviting the second keynote speaker on this afternoon or in the morning from Germany, Professor Thomas Ruder. He's a professor of hydrogeology at RWTH Aachen University. Now he is head of the Institute of Hydrogeology and rector delegate for the cooperation with Indonesia of RWTH Aachen University. He is the project coordinator from the RWTH for Get In C0, which is a German-Indonesia Guild campus in Indonesia for competence in education and research for organization. The cooperation between UGM and RWTH Aachen University supported by BMBF. And he has a lot of extensive research on flow and transport in aquifer system used for water supply, geogenic arsenic and uranium in groundwater, mine drainage and groundwater protection, tracer test and hydraulic test, hydrogeological and numerical modeling of aquifer and groundwater remediation. And he was my co-supervisor when I got my PhD when I studied in Aachen from 2004 to 2007. Please, Professor Thomas Ruder, he will give us today two presentations. The first is about the water for big city, which is the challenge between local wells and centralized water supply from rural area. And also he will give us a brief explanation about the project of Get In C0, which is now he's become the project coordinator of this program. Please, Professor Ruder, the time is yours.
Yeah, thank you very much, Bardoni. It's really a pleasure to be a speaker in this session with one of my, co-advisor, former PhD student. It was really a pleasure to have you here in Aachen many years ago, and now to be still on a good contact. And I share this in this saying of Professor Watanabe-san. Yeah, but we had really big pleasure to work in our groups. And it was also nice from you to have this full reading of the short thing Get in Cicero, so I can stay with the very easy speaking short letters. But before doing that, I will introduce first to the audience and for later discussion some thoughts about water supply. As working in this business, it is a topic we are really, I would say, every day in a big push. So let me see, looking for my slide. Here we have, okay. So you have this now in full screen, yeah?
We cannot see your slide.
I try again. Yeah, wait. It's here, this one. But now, yeah?
Okay.
Okay. And you make it here. Good. So, water. This conference dealing with challenges on geo-resources, geohazard for big cities. So in this coming minutes, I'd like a bit to stress out some messages you maybe already know when we are talking about water supply for big cities and for the coming challenges we will have to deal with these service for the public. My talk will first bit share with you ideas and thoughts about what is the starting situation, what is the scene. I will a bit give you some understanding about my saying on this topic, enlightened on two examples from developing countries and two further examples from Germany. And then I will close with some statements, and that is maybe some inspiration for the discussion later on. So the scene is set by human development. The United Nations have already established that the population living in cities is heavily growing and will overcome very soon the population, the worldwide population living in rural areas. And that means that we have to bring more and more water into the city areas, extracting this water from the surroundings of the cities. And I will demonstrate on the examples that an inside city supply of water for drinking purposes, for industry, for growing wealth of the people is in the long run not sustainable. We need some strategy, some contract between people living in city areas, people living in the rural areas. And that is a problem going more and more to every country. The only difference is that we have started with these problems maybe earlier in Europe because of the Industrial Revolution in the 19th century, but with the spread of wealth in many further countries around the world, the problems are mirrored again. And it is a good way maybe to share experience and understanding about this. So two examples to start with. This example is well known, I think, to most of you. We had already a presentation about the situation in Semarang on the northern coast of Central Java. And one of my former PhD students, Thomas Botanto, who is now working at the Diponegoro University, has already published this map of Semarang showing the areas prone to saltwater intrusion from the coast. Some areas are more often flooded by seawater, and here in this city area around the harbor, and because of the type of sediments further to the east, you will see in this red an area which is highly influenced, highly vulnerable to salting. And that means in the long run, we are losing this area for a supply of water. Let me say on this point, it is not only talking about drinking water, but even if you are washing your clothes, if you are doing a showering, I think it is unacceptable that this water is of bad quality, because it's quite easy that you are taking these things in, and we need also for that a very good standard. So it is already well established since many years that Semarang has this very high subsidence. And this is one of the many published presentations about the rate of subsidence. A former German scientist, Kühn, has worked for many years with colleagues in Semarang about this use of satellite data to establish a subsidence map. This is followed up by other colleagues also from other countries. So I think it's really quite well known that in the north we do have subsidence rates which are going to be the highest in Southeast Asia. And this area is also in blue lines overlaid with the sections of highest decline in the barometric head. The depressurization of the aquifers by high water extraction is not the only cause for the subsidence. These are young sediments. We have huge buildings in place on top of these unconsolidated young sediments. We have areas which were built up during the Dutch colonial period to increase the industrial areas, especially in the coast. Also, this means young material not consolidated so far. So I will not go in details about that, just to stress the depressurization is one reason for this high subsidence rates. And Duas Putanto has already worked in his PhD thesis about the hydrogeological model and the groundwater flow modeling for Semarang. And from his thesis, I gave you data he has compiled to demonstrate this high loss in barometric head with depressurization of the aquifers, complicated systems because we have an upper and a lower one aquifer. The data shown here are for the lower aquifer, for the confined aquifer. Prone to saltwater intrusion is mostly the upper aquifer. But there's a connected systems in some areas. So we have to think about the complete set of aquifers to understand the system. Visual influence of this subsidence is flooding. Flooding not only coming from the, sea area by high tides and spring tides, as shown on the lower diagram. These are diagrams coming from the city authorities in the city planning, management plan for the coming decades. But we have also the problem that from the countryside, from the south, we have flooding events, especially as the drainage system is getting more and more flat. With the subsidence, we are losing the necessary gradient in the sewage systems and the drainage systems to divert water out of the system. So I stressed the problem with the saltwater intrusion, but you see also with these flooding, we have further problems, and we heard yesterday already about some really complicated business already to make safe buildings in such an environment. Further example, water supply in cities is coming from our research with colleagues in Mexico, in San Luis Potosí, which is a 2.5 million city, million people inhabiting city, just 5-6 hours north, 6 hours by driving north of the Mexican capital. It's located in a basin, and we had developed a numerical groundwater model for these 2,000 square kilometer wide groundwater basin, San Luis Potosí Basin. And from this research, I like to stress one further argument for my later saying that we have to get rid of this inner city water supply. You see here groundwater contours for upper aquifer going west to east, and the lower confined aquifer you see with drawdown cone just beneath the city. The area, this symbol of my hand is rotating, is the city area. So we have inflow from the mountains and from regional water, even a bit from the, let me say, east, and an outflow mostly to the northeast of this basin. So my PhD student, Lisa Queenan, had developed a lot of data about the pressure heads in the past, and from that she established this is a gross mean value 0.6 to 1.8 meters per year over a period of, let me say, 50 years of decline in the piezometric head, especially in the city center. Here's the outline of the San Luis Potosí city, the total basin. Some areas we are gaining water, but especially in the center, we have depressurization in the lower aquifer. This schematic cross-section gives you some values about the water balance in this basin. And you see here some inflow data coming from a regional inflow, from intermediate, from the mountains, and something which is quite local. These are 1 million cubic meters per year. We have some urban recharge water which is extracted from the aquifers to water, for example, parks. We have leaking sewage systems, we have leaking mains. So in total, 3.5 million cubic meters. You see also a leakage through these confining layer. From our modeling, this is going to 50 million cubic meters a year. And it is not only a volume, that means also a way of transporting contaminants. At the moment, not really visible. And this means not to look on the main chemistry, because the main chemistry is the same between both aquifers, as most of the water used in the city is coming from below storage, nearly 130 million cubic meters a year. And the most important source for that is this regional Pleistocene aged water. We have already established some carbon-14 values, so we know that this is quite an old water, which is nowadays in this area of Mexico mined. It's not really a sustainable use of water in the long run. So, and these 50 million cubic meters is really a problem, because with that we can transport everything which is done in the city, not only in this upper aquifer, but also to the lower one. The drawdown cone I have shown to you is indeed infected by the seepage of water. Without that, the drawdown cone in the lower aquifer would even be wider than we are actually mapping, because the seepage at the end of this confining layer means here in the north is a bit limiting the extent of the drawdown cone. So, looking on the time shortly, 2 examples from Germany, some things we have encountered in our history to learn about. I will show you some information from my actual place here in Aachen. And in Munich, I have also worked for some years in my career in the southeast of Germany. So water supply of Aachen, of these 250,000 people living here in the city, is organized by some public companies, also delivering water to our neighbors in the Netherlands, just across the border. Here's the city of Aachen and the municipalities in the north and east of Aachen. And the backbone for our water supply are these bluish reservoirs, which were built in our hilly areas south of Aachen. From there, we get 35 million cubic meters a year, and 9 million cubic meters a year is coming from galleries and well fields inside the city area. Some details about that. Here are the well fields, the galleries in limestone in the south of Aachen, and we have a well field in the east. Here is the city center. This is 9 million cubic meters a year. But the most important source are these dams. And you see through the development, Aachen has established the first gallery in 1870. At that time, the people were aware that the quality of water inside the city is not good enough anymore, and also the volume is not enough for all the activities. So the decision was to build new sources in the south, quite in the vicinity of the city. Later, we moved into the mountains, and you see it has already started at the beginning of the 20th century. And with the time, we enlarged this system of dams supplying the city. The dams have also other purposes. We take only 1/10 for drinking water supply to Aachen from these dam sites. So there's a long distance transport by some tunnels with a final water treatment plant here at the outlet of that system, and then we divert it to the north into the city. Another example is Munich. Records in Munich show already that they start in the 16th century with the first duck wells erected by the municipality to supply the people. And the complaints about bad water quality have already started in the middle of the 19th century. So the water system surrounding the former city of Munich was not good enough anymore for a safe water supply. And they made plans to move water supply out of the city. First things was established 40 kilometers away from the city center. Here is the former city center. There's a 40-kilometer distance. It was erected at the end of the 19th century to bring water into the city, and it is still on the main water source from Munich with 88 million cubic meters a year. It is 80% of the water of the nowadays 1.6 million people living here coming from that source. They have further galleries and well fields put over time into this area to get this total amount. Second source established in the 1980s. We have already started in the 1960s with the planning, and the first wells were built in the 1960s, artesian wells of a tremendous good well flow. You see that 6 wells were enough to produce nearly 80 billion cubic meters a year of well flow rate. That's a huge value with no energy need. Coming from gravel established here, and it is 80 kilometers to go to Munich. So the long distance supply for the people in Munich from gravels here just at the foot of the northern calcareous Alps. And so the water we are extracting here is replenished from the high mountains you see in the background of that photograph. So 20% of the water is supplied from there. Munich has also erected some well fields around the city, especially in the period you see this long 30 years duration to bring up this water supply. And this was the measure in between. There were a need for further water. The new source was not ready, so we installed some well fields. But these well fields, which are now used only in emergency cases, it's only good for 5%. Of the water needed. So 20% is coming from the south, from the Nümen-Leusach area, and this intermediate measure was really something just to fill this gap in supply. And then you have a look on the water protection areas for these well fields around Munich. You see the city with these motorways circling around. And these protection zones are like a mosquito swarm in the south and southeast of Munich. That is just good for 5% of the water needed in the city. So having these well fields close to the city would be even a big hampering in further development. And And more smaller villages and industrial activities are spreading into this zone. It's a very important area for the city in the future. So it was very wise of the municipality in the 80s to move to this area and to move in 1980s, even here 80 kilometers to the south, to have this area free for the future. And you see one aspect, going to a rural area sets some tension. This writing I translated, the Munich water project is murdering our home. That was the feeling of the rural people in that period living in the Loisach Valley, and it was a 20 years rumor in that area, going even in court decisions up to the High Court of the state of Bavaria to settle this. Nowadays, we know that the experts, the hydrogeologists, were right in the 1960s to say it's only 2-3 centimeters of lowering we are producing from this very protective aquifer. The saying was not true, that Munich will extract all the water for themselves, drying this area. But it was a long way to make an understanding of it. So at the end of my time, with the last slide, I will a bit inspire further discussion. And the saying on this slide is coming, as maybe you now understand, from our research the last years with our colleagues in different countries, developing things here in Germany. The water supply inside cities with duct wells, with local drill wells, some areas, hundreds of wells, is in the long run not sustainable. It causes much more problems than help. And with a future developing cities, big cities, we need a better quantity, a protected quantity, we need a quality, but it's not possible from inside the city. So we have to move out. And in some cases, we should be wise to move really out, not in the next outskirt, but really in a long distance. And that means we are moving into rural areas. And doing so, it needs a good contract between the people living in rural areas, their own needs and development perspectives, and the cities. And that is something to be settled in good context. It has also a chance, because with a big city investing in a water supply, you can also help in the rural area to establish good water sources, because you have a much higher volume of money which can be invested. As a European, looking back to our Water Framework Directive in Europe and also to some civil movements of people in the past, it is settled that water is not a commodity. Water is a people rights. Water has to be served to the people essentially by public services. We have legislation, or let me say the authorities in Brussels administration were quite wise in a battle with the people to set water supply aside from the directive about liberalization and services. So water supply is not liberalized in the European Union. The opinion about that is a bit different in the different countries because of the history, but a strengthening that water is something served to the people, a public good. And I think the best way to do so is a strong empowerment of regulatory agencies to be able to make independent decisions to inform the people. And then we also need, as academics, involvement in that, and that we have to train our students and PhD students not only about the technical things, the volume and the quality, but also how to manage these gap between cities and rural areas. And that is something we have to bring together in water supply to have this sustainable for the coming generations. And that is our task, as our people before us in the 19th century have done in the 20th century, now is the challenge to our generations at the beginning of the 21st century to make this sustainable for the coming decades. Thank you very much for listening to this presentation. A bit over time, sorry for that, but I think it is also a bit inspiring our later discussion about it. Wonderful image from Merapi, I like also to share with you, and I'm looking forward to this end of our pandemic, or let me say some measures to travel safely again and to meet us again in this wonderful area. Thank you very much to everyone.
Professor Rode, do you want to explain about GetInZero directly?
Yeah, yeah, I can do this poster directly. So I give you a new chair. Okay, so we had already prepared one poster as a part of a poster sessions on this conference, a bit explaining what is so often said in these 3 days, GetInZero. GetInZero is an outcome of existing cooperation between Gajah Mada University, especially the Department of Geological Engineering, and the Faculty of Georesources and Material Engineering here at RWTH, Aachen University. And with the GetInZero, we have started to establish a research hub of the Faculty of RWTH Aachen, the Faculty of Georesources and Engineering, in cooperation with the Department of Geological Engineering at the UGM. And from this starting point, we are looking for extending it. We are extending it in the Gajah Mada University, in the University of Gajah Mada, and we are also extending it in the framework of RWTH Aachen. And you see one of the outcomes, or you heard one of the outcomes, is my position as a rector's delegate for cooperation with Indonesia. Aachen RWTH has established this for the first time, and indicating that Indonesia is on the top rank activities of our rectorates. And from the visits we had in Yogyakarta, it is also on the agenda of the rector of Universitas Gajah Mada. So, and with this conference, it is also a chance now to extend it further to other universities of Indonesia and beyond. One step was also in 2019, the field camp, the international field camp with many students, well organized by Bardoni and his team. It was a tremendous task to have all the details ready for the people joining 2 weeks of education, of training, and especially of learning about each other and making networks. And that is the purpose of GetInZero, that we are establishing networks by doing research together, and that is also a chance to incorporate the next generation of academics and professionals to have also students in that network. You see here in the lower part, this research campus is a virtual campus. Now, we are not investing money into new buildings, we are investing money into research and education. Also into a laboratory which is installed in the Department of Geological Engineering. You had already seen in the last days some results from measurements which were done in that laboratory. We have also 4 running PhD projects. One is already now in the way to have this over defense. I think next week so it's coming to an end. These projects were funded, 2 of them are Indonesian PhD candidates, partly funded by LIPI, and 2 others are German, and if, should say, funded by RWTH. One is German, and Mrs. Sara Pena Castaño, you have already got to know as chairwoman of the session. She's already from Spain, from Castellan, from Catalonia. And one of these PhD projects, I'm talking about water, so I really like a bit to stress this, is working on Gunung Kidul, yeah, and you see the idea behind that. The work also supervised by Professor Doni Putra is on looking on this resource in such a karst aquifer. Maybe it is something we can use in coming decades for water supply in that region of central southern Java Island, Yogyakarta surrounding. This is first ideas. At this moment, we are looking on the resource, what is available in this karst system. Yeah, the system is organized in some clusters, a bit to make the fields, and just naming the clusters, you see we are dealing with environment and water and geohazards and coastal with sustainable georesources, mineral resources, petroleum resources, geothermal resources, but also with raw material efficiency and energy. So the words here are a bit pointing to ideas we had about that. And with this box about future projects, these are ideas we have worked in the last years together on discussing these topics, elaborating some applications for funding, and that is indeed the greatest challenge from my point of view, to establish sound funding for long-term cooperation, especially in a period where we are in competition with other sciences. And I feel that in this COVID period, everything is now going to vaccination, to risk from viruses, but we have also to deal with other things for the societies. And this challenge to bring this back into the mind of the politicians, of decision makers, but we need also joint programs between European countries and Southeast Asian countries about such topics. And pointing back to what Professor Watanabe-san had already explained or talked about, R&C cooperation, I think is a wonderful point that with these cooperation, get in situ with R&C, with so many other countries in Japan, and also RWTH is collaborating with several universities in Japan. It's one of the priority countries, but we have a chance to establish a triangle of cooperation between these regions of experience and to join about that. Okay, maybe this is a bit also for a triggering of the coming discussion. Thank you for the chance also to present this poster, bit more explaining our activities in Get in Cicero. Cicero is a famous Roman philosopher and statesman, and he was a wonderful talker. For sure, his speeches were much better than my own, and this is still on a challenge to get to such a level. Thank you very much for listening.
Thank you very much for the presentations. What I can conclude from Professor Rude, this is the experience of the water supply in the cities, and the conclusion which is mentioned that water supply from inside city is not sustainable. It is already, we already see that in this presentation, and we know that in Indonesia, most of the sources of water is inside the cities, so it will be a problem for the future. And the other presentation about Get in Cicero and the idea of this triangle cooperation will be beneficial not only for UGM or not only for RWTH, but also for the Japanese University and Asian University. We will discuss this later after the three panelists that is already joined us today to give I think there are three of the panelists which is come today to join this plenary session and make some comment to this plenary session, and also they comment also about the topic of this academic collaboration for sustainable development of georesources. I'm invited. The first is Professor Patrick Lasasauya. I'm not mistaken to pronounce your name, yeah, because I learned it from the YouTube. How can I pronounce Patrick Lasasauya?
Yes, it's difficult to pronunciate even for French people. It's Lassagne.
Ah, Lassagne.
Thank you very much.
And then the second is Dr. Ferian Anggara, yeah, and the third is Dr. Lucas Donistiaji. Let me read. First, maybe please return back to Dr. Patrick Lassagne. So, Dr. Patrick Lassagne is the Managing Director of Hydroscience Montpellier, University de Montpellier, France. He got his PhD in Quantitative Hydrology and Hydrology in Paris School of Mines in 1989. And then in 2017 to now, he is the Water Resources Science and Expertise Team Leader of Danone Water in worldwide. The main research area is hard rock aquifer, hydrogeology, volcanic aquifer, mineral and thermal water. And the second panelist is, is from Dr. Ferian Anggara. He is Associate Professor in Geological Engineering Department. He got his doctor in 2014 in the Department of Earth Resources Engineering in Kyushu University. Now he is the head of doctoral program of Geological Engineering Department, UGM, and head of the Unconventional Georesources Research Group, Faculty of Engineering, UGM. His research interest in coal geology and unconventional georesources. And the last panelist is Dr. Lucas Donistiaji. He is a Doctor of Engineering in Earth Resource Engineering. He got his PhD on 2005, and now he is the Section Editor-in-Chief of ASEAN Engineering Journal. He has extensive research on the field of geoscience, or volcanic system, geospatial science and technology, igneous petrology, mineral resources, and volcanology. He has a lot of experience in the field-based project with wide geographical exposure in Asia, Europe, Australia, America, and Africa. Please, I'm welcoming all these panelists, and because of the time, I hope that each of you can give your opinions about this topic, and also relating with the presentation from the keynote speakers. About each of you, I give about 5 minutes. So it can be started with Dr. Patrick Lassagne.
Yes. Thank you very much, Dr. Doni. It's a pleasure for me to join you this afternoon for you, this morning for us in Europe. And I was very interested by the first speeches that were presented during this plenary session. So maybe I would like to stress the few minutes of my intervention on maybe thinking a little bit out of the box. I will propose a debate about what Professor Rude told us about the role of groundwater in cities and the non-sustainability of groundwater used into the cities. Because maybe the European perspective is a bit different from the one from the other countries in the world. I would say that paraphrasing some Americans, maybe we are a little bit the old Europe with, I would say, not so big cities. Our cities in Europe, a very big city is more than 1 million people, and particularly in Asia, but we see that also in Africa. Now big cities are 5 or 10 million people or more. As we can still manage in Europe with two things, which are importing water from outside the city and having enough water outside the city to feed the city, first of all. And second, the concept that all the water we have at the tap is fully potable, drinkable water. This is a concept we have in Europe. But what I'm challenging a little bit is, are these concepts, I wouldn't say sustainable, but are these concepts really applicable to, for instance, Asian or African big cities or Indian big cities? Because maybe we will need to mix the models and maybe have part of the water, I would say a few percent of high quality water needed for potable water, because among the 100 liter water we use each day, only a few liters is really needed to be potable. And another part of the water, which is maybe of lower quality, and then that can be supplied, or of course, by outside the city, but also from inside the city. So, this is just a point of debate I wanted to raise in order to maybe to think about using all sources of water sustainably with various usage. And if I take a step further, maybe if I would be the mayor of a big city somewhere in the world and have some choices to do I invest millions of euro of or local currency in supplying 200 liters of very high quality water to the population? Or do I invest a little bit less on this very high quality? I have maybe two separative ways to have water, a small amount high quality, a larger amount for other needs. And maybe I can invest also in health, infrastructure, schools, and so on. So this is what I wanted to point out today, maybe to begin a debate between all of us.
Oh, thank you, Dr. Patrick. So before we continue with the discussion, I think it is better that all the panelists will can give their mind about the talk today. So I welcoming Dr. Ferian Anggara. How about you? What kind of thing that you want to share to us in this talk?
Thank you, Pak Doni. Good afternoon, Professor Watanabe. Good morning, Professor Ruja. Please allow me to share my slide. I do have some slides. Is that okay, Pak?
Yes, we can see.
Okay. As mentioned previously by Professor Watanabe, that I did my research in coal geology in Kyushu University, and I got my PhD on 2014. Then my talk today is a case study from Indonesia coal resources as academic collaboration for sustainable development of coal resources. And I just would like to pick a hot topic recently due to the release of government regulation number 22 on February 2021 state that coal ash is taken off from hazardous material list. I refer to the article from the Jakarta Post just published recently. It's today, this morning. And as we may know that based on the presidential regulation number 22, 2017, we are still rely on mostly on coal, especially for electric generation in 2025 and 2050. And during the coal combustion, we produce solid waste that we call fly ash and bottom ash, or we call it as FABA. This is an example of one power plant in Ombilin, and and this is only one power plant. And as we know, in case of Indonesia, since our energy mix mostly rely on coal for electricity generation, then we have power plant from Sumatra to Papua, from Aceh to Merauke, and based on the data on 2019, the total fly ash and bottom ash byproduct is around 1 million ton. In 2050, it's estimated up to 50 million ton if we are still relying on coal combustion. Thus, a comprehensive approach should be undertaken to utilize coal and its byproduct. And after several years discussion and negotiation, thus finally fly ash and bottom ash is taken off the hazardous waste list, and it will allow for more possible uses. Then I would like to come up to this slide actually. Then we may use our coal resources to support our energy needs, as well as utilize its waste or byproduct. And in the same time, we may initiate and conduct research on coal as unconventional energy resources to make it greener. This comprehensive approach needs strong collaboration from industry, government, and university. Actually, we can learn from Japan and Germany that utilize almost 100% of their fly ash and bottom ash for many purposes. Actually, it's not about the electric generation, but fly ash and bottom ash as byproduct to material construction, cement, chemical compound, and others. As I remember when I have visited Aachen on 2018 or 19, if I'm not mistaken, then one of our discussion is not the electric generation supported from the coal industry that will be a loss, but the loss of fly ash and bottom ash to support material construction if they abandon a coal power plant in Europe or in Germany in that case. So we are in geological engineering are more than happy to have a collaboration on resources, not only limited to coal, but all the geo resources. As mentioned previously by Professor Watanabe, that many of our staff is graduated from Kyushu University, as well as Professor Rude mentioned that some of our staff also graduated from Aachen University. Then to sum up and point it out, a topic of this second plenary session, academic collaboration for sustainable development of geo-resources are conducting a comprehensive approach to utilize our resource with basic principle of zero waste processing and to support a circular economy. Actually, during this pandemic, fieldwork and international mobilization is very limited. Our conference are the real example. However, we are also benefited by virtual meeting or classes. For example, we invited one of the prominent professor in coal geology to give a lecture for our student. This invitation actually also open for Professor Watanabe, Professor Rude, and other professor. And we are also very welcome to co-supervisor for our master and doctoral student. Since now I'm appointed as a head of a doctoral program, then we are more than happy to have a co-supervisor, to have international cooperation. We also invited international students to take a PhD or master program in Gajah Mada University. So that's all from my point of view, dan terima kasih. Thank you, Pak Doni.
Thank you, Pak Ferian. This is great. Yeah? Dr. Patrick is discussing about water sustainability, and you are now discussing about the core resources related to the fly ash and bottom ash. And actually, both of them is resources. Yeah, both of them is geo resources. that we are needed every day. So let me welcoming Dr. Lucas. I hope you have something which is we have already water resources. We have already also coal resources, and I believe you have another thinking about the resources and how we collaborate with all of these resources in Indonesia. Yeah. So as mentioned by Pak Ferian, that yes, we have a lot of the alumni from RWTH, and we have a lot of alumni from Kyushu University. So that's why we not make some triangle cooperation related with this academic collaboration in such research. So please, Dr. Lucas, I want to hear about your thinking about this.
Can you see my presentation slide?
Yes, very good.
Thank you. First of all, I would like to say hello and thank you very much for Professor Rude, Professor Watanabe. Even I met Dr. Patrick in Bromo, Tengger. Yeah, so also Pak Ferian Anggara, so suggesting that geological engineering, geoscience are very, very important, critical. And I'm very honored by studying geology, being able to visit many places by your support, and then try to contribute into many different applications that become more and more complex. Yeah, and regarding with georesources, it includes mineral resources, but as well as energy resources, but also becoming more and more important are water resources. So allow me to take a note. I agree with all the presentation and the comments, but I would like to emphasize the difficulties when we come into like real industrial application. So I would like to emphasize our experience from AUN SIDNet network, and I would like to say thank you and appreciation for Professor Watanabe, and I'd like to select one specific topic regarding with rare earth element exploration and research initiated by Kyushu University back in 2007. And it's really honor for us to be part of this regional network, working together with University of Chulalongkorn, USM Malaysia, and now recently we learned that many other universities like Yangon University also working on this topic. But unfortunately, I would like to discuss here many challenges that I must say that it is not easy when we are doing research, industrial research in collaboration with many institutions, then try to realize or to make a real economical project. And in case of rare earth element that now becoming a kind of part of critical elements is becoming more and more complex. Some parts are discussed by Pak Ferian Anggara, Dr. Ferian Anggara. He established the unconventional georesources research group in our university, and we would like to support his very nice idea. But yeah, we will see the difficulties. So Professor Watanabe already mentioned about JICA AUN SIDNet and also UGM Highling project started in 2005. So the idea we try to initiate university industry collaboration, selecting some issues, some important issues. At that time, we selected the rare earth element issues, and hopefully we becoming the pioneer in this field and trying to start with academic research, studying many different places in collaboration with many institutions, and then hopefully will be realized in good situation into real industry. And it is really, we have to say thank you again to Professor Koichiro Watanabe and his team members from Kyushu University who already support us, as well as some companies like Toyota Suso, and then some BUMN or national mining companies like PT Timah, PT Antam, as well as Sumakop, Harita, and Kapuas Primakul. So we really started this project as well as at that time with national institution like Center for Geological Survey, part of Geological Agency, and Atomic Agency of Indonesia, Batan. But this is the reality that we started before year 2010, when there was a big interest in exploring rare earth element beyond China, and we were very excited to be part of this very early initiation, and we make a lot of collaboration. But you can see that the commodity prices going up, going down, and then we have to stop the research project supported by JICA IUN SIDNet by 2013 to 2015. You see the commodity price is down, and like everyone stopped the activities. But then recently, starting 2018, there is the second wave of rare earth interest, and the problem, we face a very different governmental policy, different global policy, like Dr. Ferian mentioned about circle economy, zero waste, etc., that makes everything related with rare earth element becoming more and more complicated, the issue. So now rare earth elements already classified as critical metals, and if we going to be more green and apply zero waste management, it means actually in terms of mineral resources, we need more and more mineral resources. That's the reality. To make your car becoming more efficient, you need to replace iron into aluminium, and yes, bauxite, aluminium to make it lighter. So you need even more bauxite. And then you need more copper, rare earth element, of course, etc. So this is the reality, but then we face a difficulty when we try to continue it, the initiation into something more real in terms of industrial scale. So now, today, we are full in Indonesia. We are full of discussion among policymakers, among scientists, including Dr. Ferian Anggara, regarding with circular economy, that we can extract rare earth from coal, something that was not discussed 10 years ago. And even today, we do not recognize that coal can be extracted as rare earth element economically, but this really becoming big issue. And even the pandemic situation makes a lot of discussion that our country have a lot of possibility to extract or develop the rare earth industry, but in terms of industrial activity is almost zero, because there is no existing mining license for rare earth. So it's all about a kind of planning or discussion rather than reality. So we can see the statistic, the recent statistic. We can see after we working approximately 10 years, we are now, Indonesia are surrounded by other countries who already developed the rare earth. Vietnam already successfully developed rare earth mining some years ago. India, Australia, and Malaysia. Even Thailand, some data recently suggest that Thailand also developed the rare earth industry. And the case of Myanmar, for example, is really surprising. Suddenly, we recognize Myanmar is part of the global rare earth industry. So in Indonesia, in our country, we so far we have only a kind of resources or a kind of occurrences. We understand some potency, but in terms of reserve that are economical to be developed is still beyond our situation today. So in my generation, I like to consider myself as old school geologist. We consider actually that geological resources are abundant in terms of availability of the total resources. But to discover economical deposit are very, very scarce and very, very difficult. This is something that now becoming undervalued by many researchers, even policymakers that consider that many material can be extracted economically, but in reality, in real industry so far, we learned that only small portion of resources can be converted economically. So we are in the situation we have to convince the government and some other parties that we need to give more opportunity for many parties in Indonesia to be able to make a real systematic exploration. So I would like to close my note that first of all, we are very, very happy that many institutions supported us, and we feel that now UGM is part of global community. We are very, very happy. But in terms of future collaboration, especially in mineral resources, and more importantly, critical metals and minerals, there are many challenges, especially when we try to realize a real industrial application. There are still a lot of gap between research output and the need of the real industry. We need to demonstrate that there are some economical mineralization as well as technology that are proven to deliver economical value. And if Professor Watanabe almost 15 years ago introduced the initiation of higher education linkage between university and industry. Now today, our government introduced Campus Merdeka or independent campus, and we're still trying to find out how we use this scheme in order to make a better contribution in the development of new resources for sustainability of georesources in Indonesia, in global society. Thank you, Pak Doni. Hope not too long from my comment. Thank you.
Thank you, Pak Lucas, for your notes about the rare earth element resources. And then now we have three or five actually topics that we can discuss together. So we have academic collaboration, which is already shown by Professor Watanabe. Yeah, it takes about 20 years, yeah, to move from the research education, and also to become more globally cooperation. And then we have also heard from Professor Rude about the water problems, and also the development of the Gate in C0, which is actually the starting point, also similar like the onset. And then Dr. Patrick showed to us that let's discuss about how about if how we will use our water, because it is important also for major of the city to thinking about the source of the water. And Dr. Ferian emphasized about the core resources and how it can be used, yeah, and how it can be used, because we have a lot of fly ash, bottom ash, which is now become not hazardous waste in Indonesia just recently. And then rare earth resources also become something interesting. So anybody can starting some answer or some discussion, but I think it is better to start with the question from Dr. Patrick again. Yeah, how about the sustainability of the water? But in the end, I want to ask to make some conclusion about how we collaborate based on all the problems. that we are already heard today. But please, did you have a comment from the question of Dr. Patrick, Professor Ruder, about the water sustainability in the city?
Yeah, thank you very much. And thank you very much, Professor Lasagna, for these inspiring comments. Yeah, these are setting now the 2 poles for our discussion. And as I had tried with my slides, is a bit to point out that the observations we had 200 years ago in Europe is now mirroring again in other cities. And take the example of Mexico. It is not only Mexico City as a mega city. Most of the other cities have a size 1 to 2 million people inhabiting, you know, and they have all the same problem, that the installation of well fields inside the city is extracting on high rate on a limited resource. So it needs, I think, a more strategic planning and management for the coming years. The point you brought is, the second point was that in many countries, people are not using tap water for drinking. They are using bottled water. And that is indeed a more international behavior. I agree to that. Yeah? But when we are now in the discussion, when we are taking the drinking water from the bottled water, and maybe also for the cooking, what is the standard of water we like to have for other uses? For example, for industrial uses. You know, I know companies struggling a lot of investment just dealing with turbidity, which is too high. Even turbidity coming from some groundwater resources. Or for river water, they are extracting into the aquifer. So looking on water quality, we have a good established level for drinking water, internationally recognized and really based on a lot of data. And now we are talking about the second, we take less higher quality in water for other purposes. But what is the quality we are now accepting as standard? Is that related to every industrial approach? This company A, company B, company Z, all setting up? Or what is now the quality we'd like to accept? As I said, being in the desert of Sonora, it is not comfortable when you are showering in water of nearly 20 grams per liter salt. Yeah? Second one, I mean, I'm not drinking this water, but it's uncomfortable. And that is what the people are saying. And I know in Yogyakarta, around the train station, also there, the local people are complaining about water quality issues. But I think it's a quite good point to discuss about. What is the future we like to do in water standards also? If you say we take potable water from bottled, but what is the other things we like to do? Maybe someone likes to comment, to have a discussion about that.
Dr. Please, Dr. Patrick.
Yes, thank you for your comment. I think it could be a very tough technical debate. But what I wanted to say is that if we look at the current situation, we are not really dealing with standards. People are dealing with having water for their various needs every day, and I would say that they should surely be a debate which is beyond what hydrogeologists can input. Hydrogeologists must participate to the debate, provide technical insights, but also some other people like epidemiologists and so on, in order to build with all the society, all the people of the society, to build a common vision on how to manage these water issues. And if again I take a step back and deal maybe with Indonesia, because you spoke about Mexico, which is mostly a semi-arid country. I think that in Indonesia, you are a very rainy country. For a long time, you were only relying on surface water because the balance between surface water and uses surface water was enough. Then, due to the development of big cities, notably, you shifted partly to groundwater, which is heavily used, notably in the neighborhood of the cities, as it was well described. Maybe the future, as in other countries, when you will have taken about 100% of the sustainable groundwater, maybe we will think about recycling also, and having techniques like wastewater reuse, which is already done in arid or semi-arid countries. But I think this is the next stage, not due to the fact that you are a arid country, but due to the fact that due to the population, the water needs, the pressure on water resource will continue to increase. And just to continue the debate and go a bit further, I would say that maybe we should have all these steps in mind in order to anticipate, contribute to the research in these fields, sustainable management of groundwater resource, but the step beyond, which is how to reuse wastewater and so on, and not let it go to the sea, and so on. So maybe I don't want to get deep in a very technical debate on drinking water standards or what is a standard for a shower and so on, but to have a more holistic approach, and saying that we as applied geologists, because all around the table, I think we are all scientists and applied geologists, we need to take our part in order to anticipate the issues that our societies worldwide will face in the coming years or decades. And then just to conclude, it can lead to study what will be, how to have a good wastewater treatment, what are the drugs we can find in groundwater, in wastewater, which are not well treated by wastewater plants, and so on. So we have a huge field of research to perform to address the issues our societies will face.
Okay, I think I'm pointing out the important words that you already explained, Dr. Patrick. Recycle of the water, which is also already mentioned by Dr. Ferian, and also mentioned by Dr. Lucas regarding the core resources and rare earth element. Maybe this time, Professor Watanabe, I need your suggestion or your thinking about how about the core resources and rare earth element now in Japan? Yeah, because most of the Toyota or Mitsubishi, they now move the industry to Indonesia regarding of this electric vehicle. What do you think about this, and how we collaborate in academics to support this linking about industry needed, which is right now is increasing and increasing. Please, Professor Watanabe.
Okay, can you listen? So in Japan, the coal industry is declining very quickly. So the situation is very bad because the Japanese government decided to seek zero emission. So now we are proceeding to CCS very quickly. so it means that the coal industry is very bad. Then Dr. Filian Angara mentioned about the fly ash and the bottom ash problem. That is still a big issue, but now I think related to the coal industry, the most important is CCS. I think Filian Angara did the research about the CCS in Kyushu. How about, my question is, Ferry, how about the research on the CCS in Indonesia? It's become more important in 10 or 20 years, even in Indonesia, I guess. Did you give up or you're continuing research on CCS?
Honestly speaking, Professor Watanabe, recently my research is not about CCS, but about the coal itself. As I mentioned previously, that Indonesia and most of Southeast Asian countries still rely on coal until 2050. And if we take a look about the estimated coal consumption, it's almost the same up to 2040. But yes, CCS is becoming more important recently, and mostly it's about the CO2 injection into a reservoir. This kind of reservoir could be petroleum as well as a coal bed reservoir. But yes, during this kind of situation, since economic is declining, oil and gas price is becoming lower, then the research of CCS is quite stagnant, if not what to say, give up. I would not say give up, because some of my counterparts still conducting this kind of research, but mostly as a laboratory study as well as experimental work, not pilot project. And just for the information, this year we initiate international collaborative research on pit. So we are focusing on the pit land, how to monitor CO2 emission from the pit, as well as developing a new chemical compound to prevent pit fire in the pit land. And it's a collaboration between Sasaki Sensei from Japanese side and Professor John Esterle from Australia and some of other counterparts in Indonesia.
Okay, thank you. Actually, the Professor Sasaki is retiring this month together with me. And already the Professor Sugai-san became professor a few months ago. Then really, yeah, Professor Sugai is a good person for CCS using many other very new technology. So really, I hope you will come back to Kyushu University to do CCS research together with Ahen. Actually, thank you, Professor Thomas Rude. Actually, I visited Ahen several times. Then 2 years ago, we had the MOU with Ahen. Then actually in Aachen, I met some professors who are doing CCS research. So Professor Rude mentioned about the triangle or some kind of multi-network between us. Aachen, Jogja, Montpellier, Kyushu, that sounds very nice international research collaboration, I think. Then I guess one topic is CCS, very important for near future. Then the other comment to Lucas, Lucas mentioned about REE. We did some research in Thailand or in Indonesia, but It really difficulty is the Chinese market is have this up and down, up and down. Now China try to increase the cost of REE again. Maybe it's the RE become important again. Then in such timing, you know, the importance of the production of REE in other country out of China is becoming important. Like you mentioned the Myanmar, as well as Malaysia, Thailand, Indonesia. So I guess one possibility is to develop the research collaboration with Myanmar geologists. Actually, from our department, our laboratory, many Myanmar PhD holder already went back to Myanmar. Now their situation is very bad under army's control, but I think army cannot control anymore within a few years. Their power will finish, I hope. Then we have to think about the future Myanmar's economy. In that case, of course, not only RE, but also they have lots of mineral resources such as precious metal and the tin and the tungsten. So we did a lot of collaboration research in Myanmar. We hope near future we can have the peaceful mineral resources research and development together with Indonesian people who are from Germany or from France. Myanmar is a really interesting country for our field. So I visited many times, but at the moment we cannot. But anyway, we have a very close relationship with Myanmar geologists. So near future, why don't you go together to Myanmar for research? That is maybe the next important topics. Maybe I don't know about the really main topics of this discussion, but already in the keynote speech, I mentioned about the importance of international research collaboration to develop for the next step. So anyway, UGM Geology Group was very important collaborator for us. And also this time we have a chance to connect Aachen and Montpellier. We have a lot of partnership with Africa, especially the East Africa. My photo in the back is Kenya and geothermal field actually. Now we are focusing geothermal research in Kenya and other East African country. So some geothermal geologists in UGM, why don't to do research together in Africa? That's all. Thank you.
Okay, thank you, Watanabe Sensei. So the time is limited. So I have already asked by the committee to give opportunity to the audience to give some question to all of us, yeah, to the keynote speaker or to the panelists. So please, if you have any question, please raise your hand, or you can give the question from the chat. Is there any question? From the audience? I'm sorry, now it's a very heavy rain in my house. So maybe you not hear my voice. If there is no question, okay?
I have one question.
Okay, please.
You know, recently, not the mineral resources, but one of the geo resources, hydrogen is becoming important. When I visited France, already France is focusing to do research on hydrogen very much. Actually, in Japan, our university is the front runner for hydrogen research, but and already in Japan, we have around 200 hydrogen gas stand. Even in our university, we have a hydrogen gas stand. But I think in Europe, especially in France, I think you are more focusing for hydrogen use for the hydrogen car or some other. So I want to know the recent situation of hydrogen use in France or in Germany, and also the future, how do you say, future plan to use hydrogen. Then I think in Indonesia, probably the coal gas having the hydrogen. So now hydrogen is becoming more important. How about Dr. Lasasanya about this?
Yes, thank you for this very interesting question. In fact, in France, the French government is pushing hydrogen since, I would say, only a few months. So it's quite recent. And in my university, there are some people working in the field of process in order to improve the process for producing hydrogen from various kind of water and even wastewater. So this is so this is, I would say, the only information I have, and I would say that the region where the Montpellier University is has some startup working on the topic, and has the ambition to be one of the huge producer of hydrogen, particularly for cars and trucks, because we are on a very big highway line from Northern Europe to Spain and Northern Africa, and then it can be a challenge to feed the trucks and the cars, but mainly the trucks which are on the highways with hydrogen produced locally. And to link back this issue or this topic of hydrogen with sustainable resource or with geoscience, we are beginning to think about, but it's really a recent reflection, to think about the two ends of the hydrogen circle, which is what is the amount of water resources needed to produce it, and also what are the waste associated with this production. Because, for instance, if we produce hydrogen with wastewater, we need to purify the water, and then we will have more bad quality wastewater that we will need to manage. And the second end of the circle is how much water will be produced by these cars, by these trucks along the highways. And is there a way to have this water recuperated in the trucks, because it will be high quality water that may be reused for hydrogen production or for other uses? Or can there be some impacts on the local hydrological cycle if you have liter of cubic meter of water which is displayed on the roads? So this is the current trend of what we are thinking about this topic, mainly as a perspective of water resources.
Thank you. Actually, in my private house, I used hydrogen for the electricity production almost 10 years. Then I found that still its efficiency is not so good. But future, the hydrogen source is actually the gas at the moment. But the future, of course, the hydrogen source will become the wind turbine or solar or some other. But at the moment in Indonesia, I think you have a lot of gas and the coal gas having the hydrogen. That's why I'm asking this kind of future collaboration will become very good to do or to use hydrogen. How about Professor Rude in Germany? I think in Aachen you are doing a lot of research in hydrogen.
Yeah, exactly. Thank you very much for this question. So the German perspective, I'd like also to contribute this aspect of industrial use. We see for the small cars, it is a big move, especially of the car industry now in this electrical cars. Yeah. But for the heavy trucks, there is a lot of research also sponsored or triggered by the government in replacing the traditional machinery by hydrogen-empowered machines for heavy trucks. Yeah. So I think we will get a split in the future between electric cars for the small private use and for heavy trucks and buses based on hydrogen. The same is for the industry. Phasing out coal and nuclear plants, our politicians got aware, what is well known between scientists, that a lot of energy is not electricity, but we need heat, especially in the industry. And so we are now the problem that we have to replace heat for industrial uses. And one of the projects is now going for a hydrogen-powered steel plant to be set up in Duisburg. So this is part of the roadmap established here in the state of North Rhine-Westphalia. The government released last November a roadmap of research in this state about hydrogen. And the other 15 states in Germany are mirroring such things with own initiatives. And here in North Rhine-Westphalia, we have a cooperation also between universities to work together on this topic of hydrogen. And at RWTH, we have already established a so-called Center for Hydrogen Research, joining the activities of several faculties about production of hydrogen using green energy, wind and solar energy for producing the hydrogen, then thinking about the use of the hydrogen, especially in industrial processes. And that is also part of the colleagues in my faculty, to think about the design of industrial ovens, for example, which can be fired in the future by hydrogen instead of the classical CO2 gases or coal. And that is a challenge, I think, in every country moving in the, let me say, in the energy production to green energy, but we have also to think about heat for industrial purposes, which is coming at the moment from conventional sources. I don't know if you're also doing the same in Japan or in Indonesia. Indonesia is a bit quite comfortable. You have accepted coal. Yeah, we had to struggle with the people to convince them that we need a few more years to phase it out. Yeah, that you cannot stop in the next moment. Yeah. But also in the perspective 2050, it is coming to the point that heat sources for the industry has to be rethinked. That was a bit for our discussion, maybe.
Thank you, Professor Rudy. I think after Corona, maybe we have a chance to meet together in Germany or Georgia or in Kyushu. in Japan.
Yeah,
Flying
I
first.
would appreciate to come to your place for sure.
Oh, yeah, we hope.
Yeah.
Okay, maybe time. Donny?
Yes, what I can say. I'm sorry, Ferian, we are limiting in time. We must finish actually at 15:30, and we have already passed 4 minutes. Yeah. So what I can say from this our discussion today, that we have so many things that we must talk together. Yeah. There are so many future research that we can do together, and research collaboration is the starting point for everything actually. Yeah, and then it will be followed by education program, and maybe someday we will have a good collaboration on a joint program or double degree program, which is now is a little bit very difficult to increase the number of the student or to increase the number of the program. So with this all topic of the research, I think we can develop something in the next future. For to close this session, I'm thank you for all the keynote speakers, and also for all the panelists that you support today. And thank you also for the audience, which is already 2 hours, almost 2 hours, hear us. How about the discussion of us? So the time of this session, I return back to the committee. Thank you very much for the support. Mbak Icha, you are still mute.
Okay, thank you, Dr. Doni. Ladies and gentlemen, many thanks and all appreciations to the speakers, panelists, participants, and contributors for the high quality of presentations and for the fruitful discussion and dialogue. Starting from the academic issues, we are talking about water, coal, and FABA, and moving on to industrial research challenges and to hydrogen. We believe that your research would be great contribution to the community. And as what's been severally mentioned by all the speakers and the panelists, we are looking forward to having research collaboration with all of you in the future. Special thanks to the participants coming places from far away to share their experience with us these past 3 days. Moving along the way, Dr. Hendy Setiawan, as the chair of the conference committee, would like to deliver some announcements. Dr. Hendy, the time is yours.
Okay. Thank you, Icha, for this fruitful session. Hello, Professor Watanabe, Professor Rude, nice to meet you, and thank you very much. Dr. Patrick Laksam, also Dr. Ferian, Dr. Lucas, thank you very much for giving the insight and knowledge regarding to the our panel session and keynote in this plenary. I would like to inform. Yeah, can you see my slide already? Yeah, I hope so, right? Okay. For the announcement and paper publication, we would like to announce to all the participants, the authors of the papers, and the presenter that here is the updated important dates to all of us, not only for the presenter or not only for the authors, also for the scientific committee that assists all submitted full papers. Now we have the conference date until today, 18 March 2021. And then we would like to invite to all authors and presenters that already present their full paper in this conference. We would like to invite all of you to submit your revised full paper, because we deliver the decision letter at the beginning before the conference, as the initiation of your full paper can be accepted after revision. Of course, this means that your paper can be presented in the conference, And then for the revision, you have to address all the issues from the reviewers. So we give you the deadline from now 3 weeks. So the deadline for submission of the revised full paper will be 8 April 2021. And for the documentation, some screenshot and recording video, all of the session, including plenary session and parallel session, will be uploaded, the link and also some screenshot in the portal of the website. So all presenter, please keep your login ID and the password so you can access the documentation of all sessions in the conference in the portal website. And for the certificate, we will distribute the certificate maximum 3 weeks, 2 to 3 weeks from now. And for the reviewing process, we expect to finish the review process, including the revised version, on 14 May, because we have the contract with IOP that we have to submit all camera-ready full papers on 5th July. So please be concise, be strict with this date, because if we delay for all this process and the appointed dates, the publication will be also delayed. And the term of condition, first, to all of the presenters and authors, the full paper must follow the template of the IOP. You can check the template of paper submission on our website and also from the IOP website. And please leave the blank authorship in the Word file of your papers, because we already record the information of your papers. And please address all issues based on comment suggestions from reviewers, also from the attachment that you received in the submission system. And also during the presentation, probably yesterday or today, you got a lot of feedbacks or suggestions from the audience. Please also address. And we will have the second review that will carried out until 14 May. That will be double blind also. And this is also important. Some of the submissions, we found that some email is bounced back to us when we send the decision letter. So please clarify. All the email must be active in an active email for the corresponding authors as well as for the co-authors, because we will send the proofread of the final version of your paper on May to all of the co-authors, not only for the corresponding author, but also the co-authors. So please do not put the email that not active. For the submission, still we use the EasyChair submission system. Please update your file, your revised file in this your dashboard. And the current decision will be accepted, means that your paper already ready to proofread by you before we proceed to the IOP publishers. I think that's all for the our announcement, and also we would like to thanks to our editorial board that comes from several countries. As you can see here, we have 10 editorial board from several countries, and also we helped by a contribution from more than 40 reviewers from 13 countries, from respected field background related to geological engineering and geosciences. I think that's all the announcement from my side. Thank you very much.
Thank you, Dr. Hendy. Before we move on to our closing event, Professor Watanabe have a special request. Can all the speakers and panelists to turn on their camera? We would like to have a photo session to memorize this day. Operator, are you ready? So how many slides? What? 3 slides. So please stand by for a few seconds.
is already done.
Okay, thank you. So last but not least, we would like to invite our head of department, Dr. Agung Stianto, to officially close the event. Dr. Agung Stianto, the time is yours.
Thank you, Mbak Ica. Good afternoon, ladies and gentlemen, distinguished professor, scientific committee members, and all respected participants and presenters. On behalf of the Department of Engineering Gadjah Mada University, together with the organizing committee of the International Conference on Geophysical Engineering and Geoscience, we would like to acknowledge your active participant and contributed to this event. Thank you also to Professor Wikorita Kanawati, Professor Jundiki Ono, Professor Ramon, Professor Watanabe, Professor Thomas Rude for their kind availability in giving a keynote speech and sharing their insight in this plenary session. We acknowledge also to Professor Klaus, Professor Subagio, Professor Faisal Fatani, Dr. Agung Harijoko, Dr. Patrick, and Dr. Ferian, also Dr. Lucas, Dr. Tri Utami, Dr. Nguyen, Dr. Tipat, Dr. Tony Prakasa, and Dr. Gayatri for giving expert comment and sharing their experiences in the panel discussion, as well as during lunch talking. To all moderators, we have expressed gratitude and appreciated to your contribution in accommodating all presenters during plenary session and technical session. Thank you to all participants and presenters for their great presentation and active discussion during the whole session. We apologize if there are some any technical difficulties or problems during the presentation, paper submission and registration, and also during the conference. Finally, we hope that all of you receive many input, scientific knowledge, and also important feedback during the conference to put benefit on your study and research project. With this, I officially close the International Conference on Geophysical Engineering and Geoscience. See you again next time. See you again next event. Stay healthy, safe, and always happy. Thank you very much.
Thank you, Dr. Agung. Well, let's wrap up our event on behalf of the organizing committee. Thank you all for making your time to join us here these past 3 days. It has been our pleasure to host this event. We look forward to seeing you at next year's event. I am Icha. Thank you. Stay safe and healthy.
See you again next year, also in March.
Thank you. Thank you very much.
Everyone, see you next time.
See you next year. The ICGoeS the second and cooperation with the Japan. I hope you can do it in Jakarta. Yes. I think for the conference, Professor Ruben.
But only in the coming days to follow.